Hey, what is up, students? Today, this video is going to be about rotations. As you can hear, Professor is really kind of sick. So, alright, let's see. Rotations. What are rotations? Let's say rotation is when you rotate something. Ooh, rotate around the clock. So boom, 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 boom. So when you rotate this, it's going to be in a thing. Let's see what happens when we rotate this triangle. So I'm gonna say this triangle gets rotated. Let's see, like this. Can you figure out what kind of rotation this is? Let's say I rotate it around this point, about this point. So every rotation needs a point to rotate. Let's say A, B, C, and can you guess where they are? A, C, B. Nice. Okay, if we want to find how much I rotated about, we have to find what the amount of rotation is. So let's see. Um, I'll make this line to this point to the center, which I'll call D for Professor Devin, as I'm very great, and this to point C. Now, this is not the best drawing, but you can see that it's more than 180. So let's say it's kind of like 217 degrees rotation. If it goes this way, it's clockwise, right? Yeah. Alright, now we're gonna do what else? What else? Oh, never mind. Once you figure out what amount of rotation this is, clockwise, you have to write it 217 degrees. Now, if you want to do the proof, as Daddy Daddy will tell you, it would be let's see, triangle ABC is rotated 217. You have to put degrees about, no, you have to put the direction clockwise about points. That's D to map onto A prime, B prime, C prime. Because rotations are rigid motions, as everything else was, ABC is congruent to A prime, B prime, C prime. Nice. Good job, students. I'll give you a bone or whatever. I'll give you candy, like a van, like a kidnapper. I'm gonna do stuff if you don't subscribe. Hey guys, hey students. So I want to talk about rotations on the coordinate grid. But first, I think we should talk about what happens when the points is in the origin. Okay, point of rotation is in the origin. Now let's say we have a square, a rectangle rather, rectangle right here. What would happen if we rotate it 90 degrees counterclockwise? Most rotations are counterclockwise, so you gotta figure it out. So rotate, it would look like this. It would look like, no, not here, 3, 4, like this. It looked like that, right? How would this 90-degree counterclockwise? Okay, let me draw a line. So from here, this point to here, which is the new point, is 90 degrees. Okay, 90 degrees. Yeah, no, yeah, yeah. 90 degrees. It's supposed to be better. So A, B, C, D. Now this D prime and C prime and B prime and A prime. Notice how orientation stays the same. This is clockwise, this is clockwise. So this is 90 degrees, bam bam. Now we want it 180 degrees. Okay, let's see, 180 degrees, what will happen? First of all, D would be over here, and it would be like this. Why? Let's see. Let's use example A. A right here, and let me change the color, indigo. I like that. So from D to this, which is the long side, this. This is a 90-degree angle right here as well. So that's another 90 degrees, right? So it would be D prime prime, A prime prime, B prime prime, C prime prime. Now, okay, let's see. The last and final one is a 90-degree rotation clockwise, or rather 270 counterclockwise. So let's see how would that affect the thing. So it would be right here, 3/4. How would that work? 90 degrees, 90 degrees. Nice. Now we can see, let's see. This is, these are closest, so D prime prime prime, A prime prime prime, B prime prime prime, C prime prime prime. Now let's look at the coordinates. If A is originally 6'2", like my feet as well. I'm 6'2", 6'2", 6'2", and it changes from negative to -2 and -6. -2, -6. Wait, this is -6, 2, -6, 2, -6, 2, to -2, -6. What is the relationship? We can see that it would be y, because no, -y, because this is -y, and stays x. This is a 90-degree counterclockwise rotation. And every 90-degree counterclockwise rotation would be -y, x. Now let's see what the new points would be. So from -2, -6 to 6, -2 to 6, -2. Once again, it's a -y and x. But once we want to find how it changes from -6 to 6, -2, it's a negative x and -y. Also, you can see that -y right here, -x, and x right here, y. And you know, and this is 180 degrees. no matter which way you go. And last of all, it would be okay 6 negative 2 2 2 okay 2 6 2 6. What is it again? Negative y x, so negative y, so 2, and x 6 2 6. Wow. And this would be a 270-degree counterclockwise or a 90 degrees clockwise. Same for this would be 270 degrees clockwise. Alright, now we have the formulas. We have to put the formulas that go with the original equation. So this would be negative y x, negative y, and last of all, negative, no, y negative x. Y negative x because of y. Okay, now we can do the proof, and let's do the proof right now, actually. Let's say ABCD is rotated 90 degrees counterclockwise about the origin, because that's the points of center points now, to map onto A prime, B prime, C prime, D prime. Sorry, ABCD rotated to map on it because rotations are rigid motions. ABCD is congruent to A prime, B prime, C prime, D prime. Well, I guess remember that whenever whenever that test asks you for rotation, just assume that it's going to be counterclockwise if they haven't stated which direction. Okay, now we're going to talk about rotations, not on the origin. So let's see here. Oh my god. Down. Okay. Let's see now. Rotation off the corner grid. I mean, off, like, I don't know, somewhere else. Let's say rotation is on point A. What would B be? Well, you can see that this is a 90-degree angle and 3 distance away. Remember that rotations do not change the distance and are equidistant. So B would be over here, 90 degrees clockwise, counterclockwise rather. B would be over here. A, because it's on the point of rotation, it does not change. So this would be A prime, B prime. Now AB from here to wherever. Let's see, where would the perpendicular bisector be? Like over here somewhere. 4 up. Yep, over here. That's perpendicular. And D, finally here. This is a 90-degree rotation counterclockwise on another point rather than that. Now let's see like a rotation not on one of the points, but still not the origin. Let's see C prime 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 B prime prime prime. A B C D prime prime prime. Now, okay, let's see. This is 2 away and 1 here. So it would be, if you were to do 90-degree rotation clockwise, 2 away to here, it would be 2 away to here because it's a 90-degree. Let's see it. 90 degrees. Check. 90 degrees. That's so hot. And so we would put B over here. Ours. B for A. A would be, let's see, here. Now 3 units. Would that look like 3, 1? No. No, 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 no. 3, 3. 3 would look like, so if this was 2, like this, then this would be 5, 1. So 5, 1. This is A. This is A. Prime, 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 prime. And let's see. This is 4 away. We can figure out the rest because it does not change the size or the shape. So this would be D prime, 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 and C prime, 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 prime. Nice. So like basically, if B is 2, like this kind of shape, we rotate this shape 90 degrees, it now look like this, and it goes right here. Whatever way you can rotate, I mean, you can rotate your entire screen or paper to see what. Well, never mind. Let's not do any questions, because I couldn't find any. So I'd say let's do transformation, like glide reflections or glide transformations. Glide transformations. What are those? You might be wondering, what are glide transformations? What are glide transformations? That's how you sound like. Ugh. Glide transformation is basically when you do multiple transformations, like translation and reflection together. I mean, not together, but one after another. And you would have to know how to write these rules. Like translation 3 units right and 4 units down. Then it's R for reflection, undercase R, capital T for, I don't know, the x-axis, and capital R for 90 degrees counterclockwise or something, right? And you would write these as this little thing. So if you were to do a reflection first, you would put it on the right side, reflection with the x-axis, and you would do a translation after 3 negative 4. So the reflection goes first, then goes to translation 3/4. Let's tell you how that works. Like, so reflected over this, then translated 3 negative 4. Probably looks like somewhere here, and yep, there you go. Alright, now use what you have learned in all of my videos so far, unless you haven't watched them, which you should, or else I'm gonna come and find you. And uh, you should do these problems. Alright, take a second to do those problems. Okay, back. Let's start with number 30. In the diagram below, triangle ABC and XYZ are graphed. Use the properties of rigid motions to explain why ABC is congruent to XYZ. Alright, let's see. Now, Okay, how do we get Z to C? Okay, let's see where the coordinates are at first. So Z is, let's see, -1, to C, because C and Z are corresponding and Y or B are corresponding. So C to Z, that's 1 to 1. There's a couple of things we can do to get this. We can say, let's say, we can do a reflection over y equals -x, since we know that that's y negative x. Or we could do a rotation over, let's see, 180, rotation of 180, because that's -x, -y. You can see, yeah, 1, 1 and -1, 1 are like that. Alright, but we have to prove these other ones, so let's see how we can prove y is equal to b, yb. Okay, that's -5, -1, 2, 5, 1. 5, 1. This is very interesting. Now, let's see that whichever equation is better. So, -5, -1 to 5, 1, rotation of 180 will fit. So, we can see that we can use rotations, but now let's do the final one to check. Sorry students, there's a kind of gap in here, so I just wanted to let you know that. I don't know. Look
Wait,
what the cat has dragged in. My friend, Professor and partner, Professor Kayden, is right here. Let me finish this first question with you guys first. Okay, using property of rigid motions, we can prove that ABC is congruent to XYZ because because we first actually no, I think you can do it in a better way. ABC is rotated about the no rotated 180 degrees about the origin to map onto XYZ, triangle XYZ. Remember to put the symbols or else you're gonna fail, like Professor Kayden, this bomb. And because rotations are rigid motions, as I've said many times, ABC is congruent to XYZ, what the problem has asked for. Alright, so next problem, we can see in the diagram below, triangle AVE is congruent to CBD. Alright, I want to let my professor, wait, I'm gonna let Professor Kayden take you on this problem.
Alright, what's up, guys? So, now, alright, sorry about my mic, but, alright. So, we're given that ABE is congruent to CBD, so we can write that as our given. Alright, so, we want to prove that triangle AFD is congruent to CFD.
AFD, what?
What do you mean?
Oh, AFD.
AFD?
Oh, I see.
Yeah.
AFD.
Alright. So according to my calculations,
What should we do, Professor Kayden?
we've identified that AFD and EFC are vertical angles by the vertical angle congruence theorem.
Oh my God. Wait, let me break that
Yeah.
down. That's like smart. So angle F, wait, angle. I can't write angles, or can I? Wait, I can. Angle AFD is congruent to what's it called? Angle AFD. Oh my God. CFD. FE by vertical angle congruence congruent. Oh my frogs. Theorem.
Hey, can we not swear? Can we not swear?
Oh, can we shut up? I'm writing. Can we
Alright,
shut up? Alright, what next? What next?
alright. So, I think you should draw out triangle CBD and next to triangle ABE. Just draw it out.
Uh
Not
oh.
visualize.
Let me just
Just delete that.
Yo! I almost crashed. I almost crashed. Okay. Wait, how do I
Draw it
draw?
out, draw it out.
I'm drawing. I'm drawing
Okay,
like this, right?
yeah.
Then flip it, rotate. Flip horizontal.
No. Keep it like that. Keep it like that. Yes.
Okay.
No,
Okay.
keep it like that. Keep it like that. Okay. Okay. Now, let's label it now. So, angle C will be on the top. Alright. And, yep. Keep going. Yeah, CBD. Alright. So, you guys see how, since triangle ABE is congruent to triangle CBD, we know that angles A and C are congruent based on CPCTC.
Oh, CPCTC.
See?
Congruent
Yes.
parts of corresponding triangles. Corresponding parts of congruent triangles are congruent.
Yeah.
Yes, sir. So we can say angle A. So angle A is congruent to angle C because of CPCTC. Since we know ABE is congruent, as Kayden said. Nice.
Alright. Now, we can either solve this problem by the AAS or the ASA. Now, let's figure out which side is congruent.
This is very interesting. Hey,
Very interesting.
wait a minute.
Wait. Okay, I got an idea. Alright. So, you see segment CD and segment AE?
Yes, CD and AE. They are congruent.
They're congruent.
They are
Mhm.
congruent. Wait, so they are congruent. These two are congruent. I cannot draw that out, but wait, actually, yeah, I can. What next?
Alright. That means that we can set
Okay,
these
students,
points
after a bit of
equal.
technical
And
difficulties with our brains,
I don't know how to do this.
we can see that since CD and
Let's come back to
AE
the video.
are
Come back.
congruent by CBCTC. What? Okay.
Yo, Professor. Let me talk. Okay. Alright. So as we can see, we know that segment CD and segment AE are congruent, right?
You mean
We
ASA,
can either
right?
solve this by the AAS or
What?
the ASA. Now let's go for AAS. Now, as you
hell?
can see, look at segment FE and segment
AS.
FE.
ASA.
I mean, what?
Are you serious right now? Are you serious right now?
AAS.
You wanna fight?
Ass.
You wanna fight? I'm gonna stop recording. I'm gonna stop recording and we were gonna box it out. Let's
serious right now?
Let's go. Yeah, I'll fight. Yeah, I'll fight you. You want it? You want it? Yeah, that's right. That's right. Bro, you're getting
Okay, let's
fucked.
go. Yeah.
Hey, students. So, we can rotate some CBD by 90 degrees counterclockwise. 90-degree counterclockwise. Do you have to put that in the proof? I don't know. I've never done this. It will look like this, right? It will look like this. Now, what does that look like? Ooh, now you do a reflection across AB. Reflection across segment AB. Alright, Professor Kayden, what now? We can say that these are congruent now. These are
Yeah.
overlapping each other.
Yeah.
I love Pisco.
And now we can see that when we map it onto each other, we see that AF is actually congruent to CF,
Oh
which
my.
completes ASA.
So, we can basically say segment AF is congruent to segment CF because of what? Because of
Because
because
we're able to wait. What the
rigid motions.
rigid motions.
Is that a like valid proof?
Think so.
Okay,
Oh, yeah.
students, I think you need to like add that you did. Okay, okay, rotate CBD about point B, then reflect CBD cross segments AB. I think you
To
need to
map
put that
on
first
to map onto triangle AFB.
to map onto ABE.
AFD.
What?
Oh yeah,
ABE?
ABE.
CBD, AFB, ABE, and what is this? This is just like rigid motions, right?
Yeah.
Rigid motion. Ah, no, isn't this just like a glide reflection? I don't know how to prove this. Oh, no, we prove this because ABE is congruent to CBD. That's why we can do it, because ABE is congruent to CBD. And now we can do this because of rigid motions.
Are you
Nice. Wait, am I done?
done? Are you done? Are you dumb?
Am I dumb or am I done?
Are you dumb?
Please pronounce your B's or your N's.
Are you dumb?
Yo, this is why your mic is shit, bro. I can't even hear you. I can't. Bro, I'm gonna get this video demonetized if you don't speak up.
I said, are you dumb?
Now you're getting Swiss cheese, bro. Actually, okay, let's move on, students. Forget about this loser. Two distinct. Okay. Okay. They know you. You know they can hear that. Yeah. Yeah. A B C is congruent. No. Let's draw these out first. You can. I bet you can read because you're my students. First of all, then let's do the B's and the E's are congruent. Now, which one can map onto? We want to do triangle congruence theorem, right? A congruence. Okay, let's see. I'm getting A into D and C into F. This does not work. Why? Because of AAA being a similarity theorem, not a congruence theorem. Now let's see, AC into DF, AC into DF, and BC onto EF, BC onto EF. Side-side angle does not work, as it just doesn't. So we can cross that out. ASS. I remember that because it stands for ass. C onto F, C onto F, and BC onto EF. Angle side angle, this one works. It's number 3. But also, let's see point A onto point D. Why that's wrong? Point A onto point D. Point A to point D. angle AB to DE. There's not enough information given, so no, it's gotta be 3. And remember why these all worked, because when there's a sequence of rigid motions, it proves congruency. So therefore, hey students, so what I was gonna say when my mic suddenly cut out, I was going to say you should have to do it in 2-column proof, and also add that ADF are congruent by ASA congruence theorem. That's all. Anyways, guys, students, I hope you enjoyed that video, and I hope you learned something, and prepare for the next regions in, let's see, 4 days. Wow, that's a really fast time. And better prepare for your deck as well, because it's gonna be really soon after regions. Alright, now I'm gonna see you, students, you cuties, you cutie patooties. Better like that button, subscribe, comment down in below what you liked about this video, and comment also Kayden sucks massive div, and I will see you in the next video. Share this with your friends as well. Bye bye.